Okay, so coterminal angles are angles that have the same terminal side, the same ending point. So not only are coterminal angles created by measuring an angle both in the negative and in the positive direction, but they can be created by doing so more than one revolution. Angles can have more than 360 degrees. If it means more than 360, that just means it's going around the circle more than once. So here's a quick example that I think we all understand. Is you have 0 degrees, right? 0 degrees is our starting point here. But if I were to go a full revolution around the circle, then it becomes what? 360, but it's still the same location, right? I just gone one full rotation, but my terminal side is still the same. It's still the same quote unquote angle measure. It's just that it took a little bit longer to get to the same point because I had to go a full revolution to reach 360. So coterminal angles can be found at the same location, just another revolution more or less. So to find a coterminal angle, we can just keep adding or subtracting 360, and we end up in the same location for the terminal side. So every angle is always going to have infinite numbers of coterminal angles because we can keep adding 360 to any angle, it'll still go back to the same place, right? Because or it's just more rotations, but it's going to end up along that same angle, that same terminal side. So that's really the extent of it. To find a coterminal angle, we either add or subtract 360. And that angle is going to end up, it may take a different route, but it's going to end up in the same side as that starting terminal side. Okay, so example 1, find one positive and one negative coterminal angle for the given angle. So 30 degrees is the same as saying 30 plus 360, which is what? 390. And what's a negative version of 30 degrees? Minus 360, right? So just here's a quick visual representation of why these are all the same angle measure. So you know that 30 degrees is just from the standard position, it's just 0 to 30 degrees. Okay, so that's the terminal side, right? Now, if I do 390 means I'm going to start at 0. I'm going to go a full 360 and another 30 more. So 390 is going to end up giving me the same angle measure as 30 degrees. It's just I'm having to go a longer route to get to that same angle. Negative 330, which is be taking starting 0, going in the other direction, going counterclockwise. I'm sorry, clockwise. If I go clockwise 330 degrees, that's less than a full circle, but it's still going to end up giving me the same location. So these are all quote unquote 30 degrees. It's just, it takes a different route to get to that same angle measure. Does that make sense? So we can have infinite numbers of coterminal angles if we just keep adding 360. If we keep adding more and more rotations around the circle, we can still reach the same angle measure. Okay, try part B. Okay, any questions there for A and B? Okay, for part C, if something is not in degree form, this is in radian form, we can convert it to degree form and add or subtract 360. We could also leave it in terms of radians. Instead of adding and subtracting 360, we'll just do what? Add and subtract what? What's the equivalent of 360?
Pi.
Close, not pi, but what's the equivalent? 2 pi, good. So 180 matches with pi, 360 matches with 2 pi. So I can add 2 pi to get a positive coterminal angle. I can also subtract 2 pi. Okay. And adding 2 pi, if I want to do it with a calculator, that's fine. Just leave pi out of your answer. I'm sorry, leave pi out of the calculator and just attach it at the end. I'm just adding fractions here. But you can also do it by hand because 2 is the same thing as 12 over 6. So 19 over 6 pi is the same coterminal angle as 7/6 pi. It's just one more rotation out.
You also change the degree.
Yes, you can also change the degrees. But technically, yes, but I think for us, just to get that practice, if something is in terms of degrees, I want the answer in terms of degrees. If it's a radians, it'll be in radians. But technically, yes, you could convert it to degrees, do it in degrees, convert it back to radians. But I want us to get that practice that, yes, we could just leave everything in terms of radians and still get to our answer.
Like, I still converted it to a degree, and I still did that. I just thought it was easier.
Yes, you can for now, but I also want us to eventually be comfortable where we can do everything in terms of radians as well. So, but yes, technically you can convert it back in terms of degrees, do it in terms of degrees, and then back in terms of radians. But eventually we do need to be comfortable working with radians because I know it's not natural for us to, we feel more comfortable with degrees, but we're going to move towards radians as we get further along. Okay, the question here, can we ever identify all coterminal angles? And the answer is no, there are infinitely many. Now we can create a formula that will indicate, how to find each of them. But physically we can't list out every one of them because we can keep adding or subtracting 360 and there's infinitely many. Okay, so we can use this process for angles larger than 360 by subtracting 360 until we find a positive and negative coterminal angle. So if I'm too far out, I can keep subtracting 360 until I get to one negative and one positive I'm looking for. So, example 2, find one positive and one negative coterminal angle for the given angle. State the quadrant in which the terminal side lies. So, 800, that's not too bad. We can subtract 360 a couple of times and eventually we're going to get to something that we recognize. Okay. So we'll do that. Minus 360. Is 440. That's still too many rotations out, so we keep subtracting 360. What do we get? 80 degrees, right? Now we recognize 80 degrees. Which quadrant is that in? Quadrant 1. So I say quadrant 1. So that's good. We have a positive version of our 800 degrees that we recognize. How can I find a negative angle? Subtract 360 again, right? That should allow us to get into the negative region. So I have two. Coterminal angles, one positive and one negative. Now imagine the number was much larger, right? I mean, I could keep adding or subtracting 360, but sometimes that can take a little bit longer. So what I want us to do is, let's just play with that 800. I just want to kind of show you the strategy that we can do. Now for 800, it's not a big deal because we subtract 360 twice and we're already at our answer. But if the number is too large, what you can do is you can divide by 360 so that you have an idea about how many rotations out are you dealing with, okay? So I just want to kind of practice this method for larger angles that you don't want to keep, doing something like 5, 6, 7 times. So what's 800 divided by 360? .2, right? So really, I think the important thing is to understand that it's really around 2 rotations. So if I do 2 times 360, it kind of gives me an idea as to, it'll speed up the process. I don't have to subtract that many times, especially if I just know that it's around 2 rotations out. So if I do 2 times 360, that's 720. So then if I do 800 minus 720, I get 80 degrees as well. I know it doesn't seem like a shortcut because 800 is not that big of a number. But if I can figure out how many rotations it is, I can multiply that by 360 and subtract that number from my starting value, and that will get me down to the angle measure that we recognize faster. Does that make sense? So, case in point, negative 3,732 degrees. Yes, we can keep adding 360. Eventually we'll get there. But to speed this up, if I just do 3732 divided by 360, it'll kind of give me an idea how many rotations it is. Okay. So about how many rotations are we dealing with? Okay. Around 10. I can do 11, I can do 10. It doesn't matter because as long as you're close, you can just speed up the steps you got to take. Yes.
Does it matter that 3732 is negative?
Is what?
Negative?
Is negative, yeah. So if it's negative, that means we're going to be adding a number to get to the positive, right? We don't want to be subtracting, otherwise we're going to go the wrong direction. So we're going to take these two numbers and just multiply them out because we know that it's going to speed up the process here. So what's 10 times 360? 3600. So if I just add this number to 37 or negative 3732, it may not get to exactly where I need to go, but it'll just speed up the process. Because I don't have to keep adding 360 over and over. I don't have to add it 10 times, right? I can just get to that number a lot faster potentially. Okay, so negative 132 is not quite there, but I mean, it is a negative coterminal angle, so we can put a box around this and say that this is one of the answers that we can provide. But we're not quite out of the negatives yet, so what can I do to get to my positive? That's 360. And now we should be able to recognize this angle that we see. Yes.
Could one of the negative angles be like if you just added 360 one time?
Yes, you can. So it doesn't have to be negative 132. It can be any other negative degree that is 360 degrees away. Yeah. So you have infinitely many choices to make, but because we're trying to figure out which quadrant it's in, we always want to get to something that we recognize so that we don't have to, it'll be easier for us. Yes. Good. How do we know which quadrant it's in? So if we look at a circle here, start at 0 degrees, 90, 180, 270. Okay. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So let's look at 228. Which quadrant is 228 going to be in? Quadrant 3, because 228 is between 180 and 270.
About the negative angle.
The negative angle, yeah, good question. What's the negative angle? Same, right? It's a coterminal angle, so they're all the same angle. It's just that everything up to this point, we really don't recognize it. But once you get to something between 0 and 360, you should be able to recognize it. Right, they're all the same angle. It's just the others are harder to interpret because there are multiple rotations around the circle. Okay, let's try that same strategy for part C. So rather than keep subtracting 360, figure out about how many rotations it is, multiply that rotation by 360, and you'll be able to get to an angle measure that is quickly identified. All right, try part C. Okay, try part C. Quadrant. And you quickly find the negative version by just subtracting 360 again. Yes, question. Sorry?
You divide,
Yeah, I divide by 360 because I wanted to figure out how many rotations it is around.
right here, rounded and,
I could have done 11 as well.
okay.
I just want something close, right? If I'm off by 360, it's quick, it's easy for me to get to where I need to go. But what I want us to do basically is I want to save time. I didn't want you guys to subtract 360 10 times before you got to this, right? If you divide by 10, sorry, divide by 360, and then multiply by that number, whether it's 10 or 11, you'll be able to get quicker to this than subtracting the same number 10 times, 15 times, whatever. Yes.
It's like, if we do, like, it's like 365, is that okay, or is that like too far out? Like positive numbers? I'm just asking, kind of like up top, like, for example, one, like B, like negative 394, you can add up like 0 to 360, is that okay? It's not like, does that make sense?
Are you talking about part C or, here, let me look.
No, sorry, from example one, is it okay to fix this one out of like 0, 3, 6, 3, 60, as long as like,
Yeah, here it stands for one positive and one negative. So you can choose any positive, any negative, as long as it's a multiple of 60.
oh yeah,
It doesn't matter which one.
okay, so is it different than this one?
This one's the same, it's just that we want to get to something between 0 and 360. Otherwise, it'll be hard to know which one.
Okay.
Okay, good. So we got a head start into tomorrow's. I'd like to come around and just check off your classwork. So if you can just show me pages 18, 19, and 20 are the ones that we did, then we're good. Okay, so show me 18 through 20. Once I check it, you can come up and grab your phone. Yeah.
Yeah.
No way. You're joking. It's not. There's no way. Oh, no way. It's a Tuesday. No, they won't go. That was like the worst one, like when it was raining. It was like. It's like pouring rain. Yeah,